We shall discuss next problem on belts. A leather belt 9 into 250 mm is to drive a CI pulley. CI is cast iron. Cast iron pulley 800 mm in diameter at 400 rpm. If active arc on smaller pulley is 150 degree and the stress in the tight side is 1.5 MPa. Find the power transmitted. Take the density of leather as 1000 kg per meter cube and mu as coefficient of friction as 0.25. So here they have given leather belt. This is the dimension of belt. The thickness is 9. Thickness is 9 and 250 mm is width. Width we shall take it as W. Width we shall take it as B also. We shall take it as B. 250 mm is to drive pulley 800 mm diameter. We shall take this as bigger diameter. 800 mm. They have not mentioned anything here whether it is a bigger diameter or smaller diameter. So we shall take it as bigger diameter at 400 rpm. N is equal to 400 rpm. If the active arc on smaller pulley is 150 degree. So theta S. Here we have to take theta S because the arc on smaller pulley is 150 degree. This is lap angle. This is nothing but lap angle. That is the angle from which the belt engages the pulley and it leaves the pulley. And the stress in the tight side is 1.5 MPa. So for tight side tension we shall take T1 and stress sigma 1 we shall take. For stress in slack side we shall take it as T2 and sigma 2. Find power transmitted. They are asking us to find the power. Take density of leather as 1000 kg per meter cube. And mu coefficient of friction 0.25. Mu as 0.25. So before proceeding we shall find the velocity. Velocity is given by pi dn by 60. So they have given the diameter and speed of pulley 800 mm diameter at 400 rpm. We shall find the velocity of this pulley. Pi into 800 into 10 power minus 3 because I am converting mm to meter. N is 400 by 60. So velocity we will get the value of velocity as so here they have given, since they have given thickness T is 9 mm, we shall add diameter with thickness. We shall add diameter with thickness. So this will become pi d plus T n by 60. (800 plus 9 into 10 power minus 3 into n is 400 by 60. So velocity we will get the value of velocity as 16.94 meter per second. So here we have to observe that the velocity is greater than 10 meter per second. So if the velocity is less than 10 meter per second we can neglect centrifugal tension. If it is greater than 10 meter per second we have to consider the centrifugal tension. So centrifugal tension is to be considered here. So we shall take the formula for power. Here they have given power transmitted, page number 291, equation 14.5a. So here we shall take this second formula. So this formula, this first formula, it is for neglecting the centrifugal tension, and this is for considering the centrifugal tension. BTV by 1000. So this equation is 14.5a, page number 291. B they have given width as 250, T is 9, V is velocity 16.94 divided by 1000. Sigma D is maximum tension we shall consider 1.5 MPa minus W is rho G, the value of W is equal to rho G. Rho is density and G is 9.81. Acceleration due to gravity. This is 9810 Newton per meter cube. To e power mu theta, mu is coefficient of friction 0.25 into theta is angle, angle they have given 150 degree, so here they have given 150 degree. We shall convert this into radians. So to convert we have to multiply by pi by 180. We will get the value as 2.61. We will get the value as 2.61. We have to multiply this by pi by 180. 2.61 minus 1 divided by e power mu theta. So the value of power which is obtained is 22.21 kilowatt. So here you need to substitute B and T in mm and velocity in meter per second, and here W you have to substitute in so density they have given 1000 kg per meter cube. You have to substitute directly. So V is again it is in meter. Here we are converting the values everything into millimeters. So here stress is 1.5, we have substituted directly. So we shall see the next problem. A flat belt is required to transmit 25 kilowatt from a pulley 1 meter effective diameter at 400 rpm. The angle of contact is spread over 11 by 24 of the circumference. So here they have not given the angle of contact in degrees, they are given in fractions, 11 by 24 of the circumference. So we shall see how to do this. If the thickness of the belt is 8 mm, mu is equal to 0.25 coefficient of friction and density 1000 kg per meter cube. This is density of belt and working stress is 3 MPa. Determine the width of the belt required. So here they are asking us to calculate the width of the belt. They have given the power here. They have given the power. So we shall write power P is equal to 25 kilowatt. Pulley diameter is 1 meter and the speed is 400 rpm. The angle of contact theta is equal to 11 by 24. Here they have given the angle of contact 11 by 24 of the circumference. So circumference is one complete circle. So one complete circle will be 360 degrees. So we shall multiply 11 by 24 into 360 degrees. So we'll get this this value as on 65 degrees. So we have to convert this to radians. So for radians we shall multiply by pi by 180. So if we multiply by pi by 180, we will get as 2.88 radians theta. Next, if the thickness of the belt is 8 mm, T is equal to 8 mm, mu is equal to 0.25, density 1000 kg per meter cube, and working stress sigma is equal to 3 MPa. Determine the width of the belt required. So width is B, we will call B as width. So we shall find out the value of width. So before proceeding, we shall find the velocity, pi dn by 60. Since here they have given diameter and thickness, we shall consider the thickness also. So here I am converting the value of diameter d in mm, 1000 mm plus 8. So we have to write velocity in terms of meter per second. So we shall convert the value of 8 to meters. Pi into 1 plus 8 into 10 power minus 3. Because this is in meters and this 8 is in mm. So 8 into 10 power minus 3. We shall put one bracket and again we shall put one bracket. Into n is 400 divided by 60. So the value of V is 21.11 mm, 21.11 meter per second. This is the velocity. This is greater than 10 meter per second. So we have to consider the centrifugal tension and we have to take this formula for the power. So power P is equal to BTV by 1000 sigma D minus WV square by 10 power 6 G into e power mu theta minus 1 by e power mu theta. So this formula is 14.5a, page number 291. So now we shall find the value of power. So we have to find the value of B, that is width. Power they are already given. 25 kilowatts they are given. B into T. Working stress is 3 MPa they have given minus. So W we shall find it. Into e power mu theta minus 1. Theta is 2.88 radians minus 1 by again e power mu theta 0.25 into 2.88. So the value of B we will get after solving this equation is 113 mm. So from data handbook, page number 311, from page number 311, they have given table 14.9a. 14.9a, specifications for friction surface rubber transmission belting, nominal belt width of friction surface rubber transmitting belting. So here they have given the standard table for nominal belt width. In problem we have got the width is 113 mm. So we shall consider the standard value. So here there is 100, 112, 125. So we shall consider the standard value 112 mm. B is equal to 112 mm. So this is from table 14.9a, page number 311.